What I've got here is the front view of a transition piece, but you will actually see that I've done it in 3D. Let me show you. Okay, color, I think you can see it better there. It comes better into place. If I keep rotating it, you will see that the blue actually has this whole color here, but I think you get the idea. I've shown you the 3D model of this drawing that I've got here. This drawing is done in first angle orthographic projection, this being the front view and that being the top view. I'm only going to do this side, A, B, C, D, not all of it as yet, just to show you how we find true lengths and how we determine the true shape of one side. If you can do one side, in this case A, B, C, D, A, B, C, D. If we can do this one side and find its true shape, we can use the same method for all other sides on this transition piece. We make use, to start off with, of something that we called triangulation. I'm going to draw myself a line from point B to point D. I could have done the same from point A to point C. It would not matter. The end result is going to be the same. But in this case, I've decided to join B with D. What I do in my top view, obviously I'm doing the front view, so I'm going to join B with point D. So now we have two triangles that fits on top of one another. And I will try and explain it like we build puzzles. So I'm going to draw triangle ABD at one side, and I'm going to draw BCD as another triangle, and then fit the two on top of one another. Perhaps that would make some sense to some people. Right, so let's do ABD first. I'm going to color in this triangle that I would like to find the true shape of, because remember we are doing development, and development means that we have to have true lengths of all sides, true shapes of each and every side. So I'm going to start off with this one. So how do we go about it? I'm going to draw myself an arc to find the true length of AD. We must remember that AD and AD that we have here is not the true length, because neither one of these two sides are parallel to my XY line. So I'm going to put my compass on point A, open it to point D, and draw myself an arc up to a point where we have a parallel line drawn from point A. I've put my compass on A, I've opened it to point D, I've dropped an arc so that this point here is parallel to the XY line. I now have to remember that point D has moved to the left side. So point D moves to the left side. I'm now going to drop this point D straight down onto that line. My true length is then going to be measured from point A. I'm going to measure that length. And we see that the length of AD is 67. I'm going to ignore the comma 3 because it's difficult to measure comma 31 on a ruler. So AD has a length of 67,3, which I am going to use as 67. So I'm going to label that. So I have that length. I know that AB, which is given to us, is 65 millimeters. So I can label that, but it's actually not necessary because it's given, but let us label that anyhow. Right, so I now have AB as 65 millimeters. What side is it that we do not have to complete drawing a triangle? And the side we don't have is the true length of DB. Because DB or BD is not parallel to my XY line, neither is this one in that case. We do not have a true length, and we need to go and find that one. So let's go and do that. I'm going to put my compass. Remember, I want to find the true length of BD. So I'm going to put my compass on point B, open it towards point D, drop myself an arc, which will have a point then here parallel to my XY line. I will draw a line from point D straight to the left because D has moved to the left. I will draw a line down and I will find the true length of point BD. That is my newfound D. Let me write that in. That's point D. So that is my true length. Let's find out what the true length size is because it's the size that is important. So from that point to that point, we have a length of 93.57. I'm going to use then a total length of 93.5. I think one should be quite capable of measuring a half millimeter with your compass. So that is what I'm going to label. My BD length will then be 93.5. So now that we have all three lengths as I've labeled them here, I will now be able to draw myself the development of triangle ABD. Let's go and do that. Let's go and draw the line from point A to point B. We know that AB is 65, so I've drawn that line AB. I now need to get point D somewhere in this area. We know that AD is 67 millimeters, so I can set my compass at 67. I put my compass on point A, and I draw myself an arc that would be a length of 67. I'm now going to draw BD that we have as 93.5. Put my compass on point B, and I draw myself that arc there, which is a distance of 93.5. Then I will label that point as point D. That then will give me the triangle if I join these marks with one another. Point A, I join that with that intersecting point. From that intersecting point to point B, that gives me this triangle that I will color in red. So we now have the true shape of ABD. The next part will then be to determine DBC. DBC. And as I've said, I'm not going to draw it the way it should be done. I'm first going to draw a triangle just someplace here and then fit the two onto one another to make it look like we are building a puzzle, a four-sided figure consisting out of two triangles. Okay guys, as you can see, I've now determined CB as well, that length CB, I've determined that. I've drawn that down to this point, drawn it down to that point. That green line that you see there is my true length, and I've labeled that true length as BC. I've now hatched that triangle DBC. We've determined DAB. We now need to get that triangle on top of it, which is DBC, and I'm going to draw that one. So I'm going to draw my DB, which I've got 93.5. And I'm going to draw my BC as well as my DC. There is DB, as you can see, I've labeled that DB, that's my line 93.5. I've made my arc of DC 30 because it was given to me as 30. So I've put my compass on D and I've made an arc of 30 millimeters. I've set my compass at 76 and I've made another arc putting my compass on B. I've made an arc of 76 and it then gives me a triangle. If that is point C, I will then join those points with one another to get a triangle, which I call the triangle DBC, which has to fit on top of this one. As you can see, the two are fitted. So how will I make this fit? Well, DB and DB here has got the same length. So those two is the lines that need to fit on top of one another. So let's highlight triangle and let's move that triangle. I'm going to take this triangle and I'm going to move that triangle into position. So I'm going to take point D. I'm going to place it right on point D. So that's the triangle, but DB needs to fit on DB. So I'm going to take this triangle, DB, the whole one of that. I'm going to rotate that and I'm going to move this up into the position B, which is there. And there is my true shape, the true shape DABC. I've got AB, I've got BC, and I've got CD, all two triangles on top of one another, which is the true shape. And that's what I need to do with all four sides. This side, this side, as well as that side. And that will then give me, at the end of the day, the total development of this transition piece. Remember that this manner or way of putting triangles on top of one another is not how it's really drawn in actual exam or question. There's a different way of doing it. I just did this puzzle method to show you how the things fit together. So I will show the true method of how it should be done in a later demo.